Hi and welcome to this first video of a series of videos that showcases the functionalities of an Austrian style motorway traffic management system that I've programmed in Python. This video presents the system's basic functionalities, which are an incident detection algorithm and a tunnel metering algorithm. A more comprehensive view of all functionalities that are included in the system can be found in other videos on my YouTube channel. So I'll now briefly introduce two of the components that you can see on screen. So on the left, right here, we have a SUMO simulation. SUMO is a German open source microscopic traffic simulation model that actually works quite well with Python. The network that I've simulated is somewhat comparable to the Dutch A12 motorway near The Hague, which means that there is a long motorway link, which you can see right there. And at the end there is a intersection that is controlled by a traffic signal controller. About halfway of the link there is a small tunnel right there. On the right we have a visual representation of the motorway traffic management system, so right here. Here we see a schematic view of the motorway link in the SUMO simulation. So this schematic view corresponds to this link. Every rectangle that you see in the schematic view represents a set of loop detectors. So here, these three loop detectors, which are directly upstream of the intersection, correspond to these rectangles in the schematic view. The color of the rectangles represents the average speed that is measured on these loop detectors. As you can see, in total there are 9 sets, or 9 times 3 sets actually, of loop detectors outside of the tunnel, so 5 downstream and 4 upstream, and there are 3 times 3 sets inside of the tunnel. Every set of loop detectors, or in fact every 3 sets of loop detectors, which is represented by a row, corresponds to a variable message sign on the right. So this second row right there corresponds to this VMS, and this third row right there corresponds to this VMS. So the algorithm that I've programmed is run every time step of the simulation, and what it basically does is the following. First, loop detector occupancies are obtained. Then, on the basis of these occupancies and historical data, speeds and flows are calculated. Speeds are then used in an accident detection algorithm that works similarly as the Dutch AID system. Essentially, this means that when the average speed drops below 35 km per hour, a queue is detected, and as soon as the average speed exceeds 55 km per hour, the queue is gone. If a queue gets detected, queue warnings are displayed to road users via the variable message signs, and the speed limit is decreased. If a queue gets too close to the tunnel, right here, a tunnel metering algorithm is activated automatically that prevents that vehicles come to a standstill in the tunnel. Alright, next up, let's start the simulation. So, what you can see here is that the first vehicles are joining the network, and right here too. So there's the intersection that is now handling these vehicles. In the meantime, the first vehicles on the motorway link have arrived at the intersection, and what you can see now is that these vehicles are also detected by the loop detectors from the traffic signal controller, which are shown here in blue. So there is a queue forming or starting to form, and as you can see now, the right set of loop detectors that is directly upstream of the intersection have detected a queue, and as a result a warning is presented to the road users, which means that a actual queue sign is presented on the first gantry or on the first VMS, and a warning is presented on the second VMS. And this will continue to go upstream for an increasing queue, which you will be able to see. So the queue is starting to become larger, and speed is already dropping at the second row of loop detectors, and as you can see it's red now, which means that the average speed is below 35 kilometers per hour, and as a result the queue warning heads 1 VMS upstream. In the meantime, the intersection, or the traffic signal controller at the intersection Bannerstad, is trying its best to make sure all these vehicles may pass the intersection. However, a queue is formed. As you can see, speed drops at the third row of loop detectors now too. Oh well, it's gone up again. Yeah, and there it goes down again. And it won't take long, there it is, before the third row of loop detectors also measure a queue. So we're now about 2 sets or 2 rows of loop detectors downstream of the tunnel, and what you will see is that as soon as the queue starts to propagate upstream and heads towards this row of loop detectors, the warning will propagate upwards and will go to this VMS, and accordingly the lights of the traffic lights of the tunnel will start flashing yellow instead of presenting green to the road users, to warn them that there is a queue upstream. As you can see now, a nice queue has already formed. And speeds are starting to drop here at the 5th row as well, especially for the left lane. And it's gone up again. Okay, so the thing that I've just explained will happen soon now, because speeds are dropping at the 5th set of loop detectors. Yep, there we go. So the loop detectors have detected a queue that has propagated up until the 5th row of loop detectors, and as a result, the queue warning is now presented on the 6th VMS, and the lights of the traffic lights of the tunnel are now flashing yellow. As soon as a queue is now detected inside of the tunnel itself, the tunnel metering algorithm will activate, and yeah, the tunnel will start metering. For now though, no queue inside of the tunnel itself is measured. However, as you can see, that won't take long anymore. So there we go. There is now a queue measured inside of the tunnel, and as a result, you can see it here, the tunnel starts metering. You can also see that a queue is starting to form just upstream of the tunnel now, as a result of the tunnel metering algorithm being active. And what you can see is that the queue is formed up until the tunnel, and the tunnel itself is free, and the queue starts to propagate upstream again as soon as the tunnel is over. So the tunnel metering algorithm is doing its job, you could say. And what you can see now is that as a result of the tunnel metering algorithm being active, there are now 2 rows of loop detectors that measure a queue, and subsequently the queue warning propagates 1 VMS upwards. A queue is now forming here as well, and a queue is still here, and the tunnel is empty. There are no vehicles, so that is good. That is the desired situation. So right at this point, no more vehicles are joining the network, which means that these vehicles are the last vehicles from the other directions to be given green, and then green can be given to this direction as well. And what you will see then is that the queue warning will start to head downstream again towards the intersection until there is no more queue, and all VMSs may be all signs on the VMSs may be clear again, I should say. So for now, these vehicles are the last that want to go through the tunnel, and they will be metered since there's still a queue here at the 5th row. What you can see though is that on the right there's no queue measured anymore. You can clearly see the speed differences here. So these are the last vehicles to pass through the tunnel, and what you will see now is that the tunnel metering algorithm, there you go, will deactivate again because there's no more queue right there, and the queue warnings start to propagate upwards, or downwards I should say. And so these vehicles are the last to leave the network again. And they've almost left. And that's it. All vehicles are now gone, and as you can see, all VMSs are now clear again. So, thanks for watching. I hope you liked it, and if so, make sure to watch the other videos in this series too. For now, have a nice day, and see you later. Bye!